Hello everyone, I'm Kristian and I love to eat. Whenever I'm in new places, I need to find a place to have dinner. So this is me in Boston in May. Simple task, I'm just looking for a place to go. It has to be open, close to me, and of course matching my preferences. So I'm using Perplexity to solve this problem. How many of you use Perplexity? Great! I was at an ML conference in New York 2 days ago and fewer people actually use Perplexity there. Anyway, so I typed in my query and this is what I got, and it looks great. It actually also estimates that I love seafood, which is correct. So Harpoonlaris is the place to go. It's a 10-hour drive from where I'm at. So I didn't do that. It puzzled me a lot. So I used Perplexity more times. I said, why is this happening? And suddenly it gave me the correct results. And the change from the previous one we saw is that now it used Yelp as the sources to generate this result. You see those red dots there. So it also recognized this is a local problem. So this illustrates that if you feed the model, Perplexity uses models like OpenAI and those to generate this. But if you feed it the wrong data, the results will be wrong. I will be in Virginia having dinner if the input is wrong. So I think this illustrates that, well, Perplexity tries to solve everything for you. It's like you can ask it anything, it says so. And the dangers of that is that you don't really control what the model will output. And if you build chatbots, bad things can happen. And Air Canada learned that, and they have to pay for it too. So there has been a lot of talk about implementing RAG solutions and how you can use this. And there are many ways this can go wrong. So trying to understand what the user is actually trying to do it and trying to solve for a small problem, make a high quality retrieval is essential to the user experience. So this is me, I'm Kristian, I'm from Norway. I used to work for Yahoo for 20 years. We've been developing our platform for more than that. We spun out last year, so technically we're a startup. Our code is open sourced since 7 years ago, so everything I'm talking about now you can do yourself after the talk. And there will be a QR code you can scan so you can actually do this. We also have, of course, an endpoint you can use as a managed solutions. Our users like Yahoo, Spotify, and other companies use Vespa to serve media to implement e-commerce solutions. So today we're going to talk about foundation models. Like everybody knows ChatGPT. That's based on a foundation model. A foundation model is trained on a broad set of data, so it knows a lot about most things. But it can't know everything, so that's why we need a retrieval system to give it more data. Like in my case, we need to feed it the restaurants in Boston to make it useful. So in this talk, I'm just going through what's called in-context learning, meaning that we will provide the model a couple of relevant examples so it can make better decisions. So it's quite a simple thing. It's based on a paper from our Scottish friends, published this year. There are many things to explore. How are we going to extract the data? How many examples should we give it to the model? Should we give it diverse examples? Will that help? What kind of model should we use, and what will this cost me? I talked with someone earlier today at the expo. He got a huge OpenAI bill. So, this can be costly. More questions. How can we use this to improve my current service? Most of you have jobs and you're looking to solve a problem, and how can we actually deploy this? So you have data in many places, and it could be databases, data warehouse, data lakes. At this point, you understand why I'm not a graphical designer. I couldn't find good examples, and the visual models, I couldn't make ones either. This is a search engine, graph database, lots of files, or a vector database. Many of you have learned reading the internet that you need a vector database to solve this problem. That's not true, but it will help. It's even better to have a system that has vector similarity capabilities, but you need more than that. So I'll pick a very simple example, and we'll, at the end of the talk, also look at how we can, make much more interesting examples. This is very boring. It's just like people trying to ask their bank how to solve problems. So these are typical queries. They type into the system, and the bank will try to categorize what kind of query is this, what's the problem. So I use this open data set. I think it's 70-something different categories with a lot of queries that are categorized. So it's super for me to run experiments. So let's do that. So this is a bit small, but at the left you see my sample data. It's from the training set. So it's the user query and the categorization. So this is like the correct answer. On top you see some queries from the test set. This is what I'm using to run this experiment. So I'm extracting those from my search engine, putting into the large language model. That's the thing to the right. It's like it's a set of examples with the user query. And I'm looking at generated category that the language model gives me. Quite easy experiment. Give it some text, what's the category? So we're going to look at, will this take time? What does it cost? And how accurate is it? So we'll start with the simplest baseline possible, which is just regular text matching. I'm from the information retrieval industry. I'm not a machine learning guy. So people have worked for decades on solving these problems, like language, you see synonyms, plurals. It works quite well, so I use this as a baseline for my testing. So amazingly, you see the light green results there, the biggest one in the pie chart. In almost 80% of the cases, by just using text matching, we can predict the category correctly. The light blue part is where the search engine extracted the wrong or predicted the wrong category, but the language model corrected it, and that happened in 13% of the cases, which is amazing. So that illustrates that this actually works. And this is just out-of-the-box testing with me doing nothing. So 90% accuracy, that's quite good. The darker green is the search engine predicting the category and the language model making it wrong. So that happens too, but only 2%. And the dark space is where it's wrong from both. So how about vector similarities? Like when we did this was just text matching, and it works great for English. Good luck if you have Chinese data. Or Norwegian, for that sake. Vectors are, this is one of the key slides of the presentation, because this illustrates how we are transforming this problem from a textual or like language problem into a numeric problem. If you need something to remember this from, think of NVIDIA, like the previous presentation. This is how they got rich, because computers love numbers, and we are transforming text into vectors. It's like a long sequence of numbers. So we don't know what these numbers mean, but we know that similar pieces of text will generate similar vectors. That's what we know. So if you compute the distance between the vectors, we will know that the text, like close vectors, means text sentences are close to each other. So we will use this to find similarities. So one thing you can think of, and this is like text to numbers. You can do this for images too, and I'll get back to this. If you're using models that will generate the same kind of, it will map to the same space in vector space, also for image. So now we have multimodal systems. So this is something you will see much more of next year. Again, a cliffhanger for my last slide. So looking at vector similarity, these are the results I got. You see much more light green. The retrieval is way better than the text matching. So this worked. And the language model is still doing its work for 4%. So 2 points better precision, which is awesome. This is still like I didn't do anything special. The intuition is that if you combine the two, it would be even better. And this is a very disappointing slide for me because it wasn't. The gospel in my company is that you need a hybrid. You need multiple signals. And most times you do. I think why it didn't make a difference here is that the text examples are very short. They are very, there are no proper names here, no addresses, no things that the model doesn't know. These are just like simple English sentences. So the text matching doesn't give you anything extra here. So we're still at 92%. So let's look at different models. So Llama is, well, you have to be an engineer to understand why people give them these names. I have no idea. Llama is a set of models that Meta open sourced. It's great for us. It's like for free from the guys that made Facebook. They come in different kinds. They can be small, like 1 billion here. The 1B means 1 billion parameters or 1 billion numbers. That means a smaller brain than 3 billion and smaller than 8 billion. So in this experiment, I did the Llama 3.1, which is 8 billion. 8 billion is like, you can download that to my laptop. It's over there. So I run this on my laptop. So think of it as a copy of ChatGPT, but just smaller. It does the same. It's amazing. Fun fact, I asked the Llama 3 model about the Sandy Springs, this center, and it knew it. So my laptop knows about where I'm at now. The restaurant next door, it doesn't. It's not frequent enough in the training set. But this location is. So it is amazing. So what you will see is that, of course, smaller models, they fail more. And in this case, I had 30% failure rate for the smallest one. So it's not useful. But it was close on target. You see, it didn't say card arrival. It said category card arrival and those things. So it was almost there. So with a little bit of coding, we could improve it a lot. So smaller models, worse results, as expected. Try the OpenAI as well. You can do that. That's the easiest solution because they have an API. You don't have to install anything. You just query it. Almost the same, or actually a little bit better, total prediction. So let's move on to how many examples should we give the system? What's a good number? The intuition is that the more the better, which is correct until some point, in this case 10, and then it gets worse again. If I give the model too much data, it gets confused for some reason. It doesn't get any better. And if you're using OpenAI, for every token extra you give it, you pay more. That's the model. So we want to find the best, the sweet spot for how much data to give to the model. This is something you'll have to test for your use case. How about different kind of examples? In my case, I used a very simple ranking model trying to find the closest ones. But is it better if I give it 10 different categories always as examples? Interesting experiment. So it clearly isn't. If you look at the dark green space here, those are the correct classifications from the retrieval system where the language model made them wrong. So not a good way for this data set at least. So this is how good I got it. It's like 94%, and this is like half a day work for me, and I'm not machine learning guy. So I could build this, like your summer intern can do this in a week next year. So it can get really good really fast, but it's not good enough. It's like it will fail 6% of the times, which is not good enough. Let's look at the trade-offs first. It will cost you if you use OpenAI or the competitors, or if you do it yourself using your local models, you'll have to run it yourself. So you have to pay for the resources in AWS or GCP or wherever you run it. And they are slower. So again, the trade-off, fast brain with less accuracy or more accuracy, but slower. The interesting observation here is also that the retrieval part of it, like getting the example, it was 21 milliseconds. It's nothing. So I didn't bother measuring that. So let's look at quality. So how to get from 94 to something better. So, and this is I'm very glad the former talk here, he talked about building the flywheels. How do we improve the data? So this is exactly what we will be doing. So most of the time, the model is right. So we can give it some kind of confidence in what it does. So we want to actually use the prediction that the model made in the next user query. And we also want to take some of the data we just got and have a human review and use that to classify so we got to 100%. So you can build that into the system too. You don't need to do anything extra other than put a confidence number of how good is the model output. And so you have a combination of the exact classifications and the generated ones, and you can combine this. All right, important message. We have lots of users, and they say, "How can I improve this?" And we say, "Well, do you have tests? How do you know?" The data is super important. That's the value of what you're doing is the data. So you need to build your data set so you can redo experiments like this. This is an example of the flywheels that he talked about in the former presentation. So the top left one is the instant, the language model, just classifying, and you can store the classification and use it in the next query. So it runs by itself and it builds your data set. Bottom left, you can do a human review, say right, wrong, and you will improve the quality. That's like a bit longer cycle. You can do it daily or whenever. The nice thing is that on the right hand, you can use this data to train models to use in your ranking as well, and your machine learning team will love this. Like this is their what they live for, data. So these are 3 different cycles that you will be building. The nice part is that you don't have to know anything about machine learning to do this. I don't. So you can build this, you can get started, you can try it on your laptop tomorrow. And we'll have some resources to help you do that in the QR code. So then you can build systems like this. The summary is, if you ask the model to do simple things, it will work. If the model outputs crazy things or you can't make sense of it, you can always default to something unknown. You can let the user at the website select herself. You can quantify this if you have the test set. You get to use AI easily, and you can control the budget and the latencies and those things. There's nothing stopping you from trying this with your service today. You don't need a machine learning team. You don't need a big budget. So you can do this. So my goal is that most of you do that. And you start with a simple problem, you have a simple win, and you can build from there. So this was a very boring example, just like very simple text set. So the more interesting developments are image models, visual language models. This is what you will see next year. We can take images, map them into the vectors we talked about, and use it exactly the same way. So you can build systems like this. I love this example. So this is just an image of a PDF. Many of you have data like this. So you can use a visual language model. You can give it a textual query, in this case, the peak power usage in Texas, July. That's the yellow line there. And the model will output in text. It's at 6 p.m. This is amazing. This will transform everything. If you're doing OCR today or some other extractions, you will stop doing that. So this is what we will see next year. If you think of what ChatGPT did for text, the visual models will do this next year for radically new applications. So hopefully you will get started doing this. I'm here today and tomorrow. Find me in the expo area at Vespa.ai and ask me the hard questions. So thank you guys.